All right, so we've spent, what, weeks here talking about DC circuits and currents and magnetism and the Coulomb force and all this stuff, and we're finally gonna have a little, 3 or 4 minute video on AC circuits, which is the way that most of us get most of our electricity. This is what comes out of your plug in the wall, and it's the AC stands for alternating current, and we'll see why that is. So AC circuits behave differently than DC circuits. DC stands for direct current. The main way they differ is that they alternate, so that the voltage is actually changing back and forth from peak in one direction to a peak in another. So like in a battery, you always have the positive on one side and the current is always flowing this way in the circuit. In an alternating current, your source has a positive voltage on this side, and then it will switch to a positive voltage on this side and then switch back to a positive voltage on that side. The current, meanwhile, is going to go that way, then it's going to go that way, then it's going to go that way. And so we can look at the voltage here, like if this was, say, our voltage on this side of our source, we'd have a positive voltage here. It would swing down to a negative voltage and back up to a positive voltage. The current follows that voltage, right? The electrons in the wire are going to go from the higher voltage to the lower voltage, right? So our higher voltage is here, our current is going to head in that direction. The voltage swings down here, and the electrons in the wire are going to swing again back towards the new negative. So as the voltage alternates, the current alternates. The alternation has a frequency f, just like a wave does. So if we had, say this was 1 second, then this would be a 1 hertz frequency wave, right? It would go through the full wave once every second. The energy coming out of your wall has a frequency of 120 hertz. No, sorry. 120 volts. It has 60 hertz. Sorry, got a little confused there in my head. So it's 60 hertz that's coming out of your wall. We can write this sinusoidal curve here in this form, where this term, this 2 pi f, is our little omega, but we're not going to deal too much with that. But this is just a way of putting this in a mathematical equation. The V naught is the full amplitude here, right? So if we have a 120 volt circuit, we're going to get to 120 volts, and then we'll get to a negative 120 volts down here. Same with the current. A lot of times we want to know what the average voltage or the average current is. What would be the average voltage of this cycle from here to there? Well, the average voltage would be 0. And so that's not a very useful number. And so we have to find a different way of calculating that average. And the way we do that is what's called a root mean square. And we won't get into this too much, but essentially what you're doing is you're squaring these numbers so that they all become positive. So at each point along this curve, I square my numbers. So I've got positive, positive. I square my negative numbers, they become positive. Then I take the average of those squared numbers, and then I take the square root of that. That's called a root mean square. It's a pretty standard mathematical process for trying to find the average amplitude of something that's going positive to negative like this. So the way that looks is we just take that to find our root mean square of voltage, for instance. We take our voltage max amplitude, that V naught up here, and we divide it by the square root of 2. So it ends up being, it sounds like a complicated process. In practice, for a sinusoidal curve, you get a pretty standard answer there. Same with our root mean square of current. And we can even carry that root mean square process over into power and into Ohm's law, as we'll see in a second here. So power for an AC current is going to be, if you remember for a DC current, it's just IV, power equals IV. Here it's half IV, right? So those 2 square roots of 2 get multiplied, and we get a half term there. For Ohm's law, we can just use those RMS values um, to find out our root mean square current from our root mean square voltage. So that's AC current. We're not going to dig into it a whole lot. The circuits work in very similar ways. As you can see, once we start thinking in terms of a root mean square, even our equations look very similar. And so we're not going to do a lot of AC circuits, but it's good to at least recognize the nature of that AC electricity.